Hi and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. We are now in the second video of our three-part segment on logistic regression analysis. We just finished cleaning our data and now we're going to analyze it. So let's hop back over to R. We'll be working with the weighted survey variables from the BRFSS sampling design. So we have to start by loading our survey library. All right, and yeah, so we've used the survey design in the video on prevalence estimates, so we're basically doing the same thing again. I've called this object cg17_lr_dsgn for our logistic regression survey design. The command is called survey design. We're setting our ID to ~1, strata to the ststr variable, and our weights to the llcpwt weighting variable. And then our data is the original cg17_lr data file. So let's run that survey design. Let's take a look at it. Glimpse cg17_lr_dsgn. That should be a G, not an H. All right, and yep, it looks good. It looks like everything's there. All right, and so in the article, let me take you there. They said that they ran a chi-square test. And I had said that if they ran a chi-square test, I'm not sure I'm seeing those results in their table. But regardless, I wanted to show you how to run a chi-square test in case that's something that you would like to do in the future. So you kind of have three options for addressing this. You can use this survey table function, where you put ~xrf health plus your health variables. So I'm using physical activity as an example. And we're using our survey design. So this survey table will give you the counts of the two categories, so the two health categories and the two physical activity categories. It will give you the counts, which are actually the weighted counts because we're using our survey design. You can use survey chi-squared, which will give you your F statistic and your p-value on those counts from survey table. Or you can call the survey table command wrapped in the summary function. And what that will do is give you your counts and your p-value and F test statistic. So let's just run these all three at once, and I'll show you what the output looks like. All right, so this is the survey table. Here are your weighted counts. This is survey chi-squared, your F test statistic, degrees of freedom, and your p-value. And this is the summary survey table function, giving you your table and your chi-squared test statistic. So if you want to do chi-squared tests, this is how you do it. But we're looking at odds ratios. We're using logistic regression analysis. So we're going to be using the survey GLM function, which is survey generalized linear model, which is similar to the GLM function in regular R, but we're specifying the survey because, again, we're using our weighted survey design. And we have used our, I'm getting ahead of myself. So what I want to tell you about this code is the function is called survey GLM. You write the function as the dependent variable on the left side and the independent variable or variables on the right side. We're specifying family equals quasi-binomial because if we look at the function documentation for survey GLM, and we scroll, one of the arguments is family, and if we scroll down to under details, we see that if you're doing binomial or Poisson families, you should use family equals quasi-binomial or family equals quasi-Poisson. And so because we're doing logistic regression analysis and our categorical variables are set between reference and comparison, we're doing binomial analysis. So we're going to use this family equals quasi-binomial. and that will allow us to avoid warnings about non-integer numbers because we're using factors, right? So that's why we have this family setting to quasi-binomial, and then here is our survey design. So let me run that for you. All right, and we get our results. These are our estimates at the intercept and for our reference value for physical activity. So in the paper, the way that they describe the results is they display their reference value and display the odds ratio for the comparison. So for example, this variable on smoking status. So if the first option is a non-smoker, that's the reference value. So if you don't smoke, your odds ratio for good health is set to 1.0. But if you do smoke, your odds of having poor health is 1.5 times higher. So they display their results kind of on the negative side. So if you do the negative health behavior, your odds for having poor health is whatever, usually increases. But we like to be more positive. So we're going to look at our reference value and actually think of it in terms of if I do this thing which the paper set as the reference. So for us, it's not actually the reference anymore, it's our comparison, right? So if I do this good health behavior compared to doing this poor health behavior, my odds for having good health increases. All right, so in the paper they display like your odds ratio, your risk for disease increases. For our analysis, we're going to look at it if you have better health, then your risk or your chances for having better health increases, right? So good health behaviors relates to better health outcomes. So that's what we're going to be looking at it as. Just don't get confused when you see their data displayed like this. All right, so when they display x to 10 to ref, this was their reference value was for meeting the physical activity recommendation. So for us, we read that as for every 0.9 increase in physical activity, you get a 1 point increase in improved health. All right, so that's how you interpret that estimate. Now, if we wrap that svyglm function in the summary function, and we run that command, we get our estimates, but we also get our t-value and p-values, our t-test statistic and our p-values. So in the table, they indicate statistical significance by putting asterisks. They don't actually include that the number of the p-value. They don't include that p-value in the table, so we won't be including it in our table. But if you wanted to go back and then include the asterisks based on the statistical significance, that's how you would do it. Okay, wrapping your svyglm function in the summary commands, and you can figure out the p-value and then go back in and put in these asterisks wherever there is statistical significance. So now what we're going to do is we're running these same two commands again, except for first setting our svyglm commands to the object called OR for our odds ratio. And we're just doing this so that we can work with this OR odds ratio object moving forward. So copy that command, paste it back into R, and it gives us the same results. What we can also call on this OR object is the confidence interval, which we don't actually have to do because we get that when we run our svyglm. We can calculate that from the standard error, or we can specify it in our svyglm commands. But I just want to show you this confidence interval function now because we're going to use it later when we actually look at the log value for these estimates. Okay, is that confusing? So what I mean by that is the way that our estimates are presented right now from the svyglm function. Those are the estimates, but in order to look at the log, in order to do logistic regression on that estimate, we need to take the log of those values. So we do that by doing exp, which is exponent, I think coef, I think is coefficient. So, take the exponent of the coefficient of our odds ratio svyglm function objects. Okay, so when we run that command, ch12, we get our value for the physical activity variable is 2.5. That means that if you do physical activity, and we've set it as if you exercise at least once per month, your odds of having good health increases by 2.5. So your odds ratio is 2.5. All right, pretty neat. But when we took this confidence interval, it was not on our log estimate. So we just include the confidence interval in this little, in our call for the coefficient of OR, and we wrap the whole thing in the exp function. And we also included this cbind command, which will bind our columns. So now we have our odds ratio and our confidence intervals next to each other. These are the confidence intervals on the odds ratio. And actually, this first line is the intercept. So we're interested in the second line, which is our health variable. So what we want to do is start building a table. So we're going to set an object called OR table, call that command again, but only keep the second row, because the first row is just the intercept. And when we do that, and we look at our OR table, now we see we have our odds ratio and our upper and lower limits. But what we lost is this indication of the health variable. So what we want to do is add a column to this table that we're building to specify this health variable. So we're going to do that by OR $HV. HV stands for health variable. And we want that column to be populated by this word x_totinda, because that's our health variable, right? And we see we get a warning message that it was coursed to a list. So when we look at OR table again, we see that it separated that line, that row, into a list. So to fix that, we unlist OR table, and now we get our row like this. But as you can see, everything is in quote marks, and that's kind of weird because this is basically an unlisted vector, I guess, and it's recognizing these as characters, I think. But what we want is to start building a table. So we want to set this OR table to a data frame. So as.data.frame parentheses OR_table. And now we have we're building a data frame where the first row is the health variable totinda, the odds ratio, and it renames these column names for the 2.5 and 97.5. Those are the margins on the confidence interval for lower and upper. Okay, so now we have the first row of our table. That is this first part, odds ratio confidence interval. That's this first part. And you may notice I'm not addressing these middle two columns with the weighted percent and unweighted counts because we covered that in the prevalence estimates tutorials. So if you want to know how to calculate these two columns, go back and watch the segment on prevalence estimates. All right, so we're just focusing on the odds ratio and adjusted odds ratio. So we've done that. So I wrote a function because we have to do all of this for every health variable. And as you know, I like to be efficient rather than doing the same thing over and over again, potentially making mistakes by copying and pasting. So I wrote a function which should have worked. Okay, so basically all of this is the same commands that we just ran here. All right, so this highlighted, this is our function that worked. And when I try to run this function, which I called OR_fun for odds ratio function, this is the function. When I try to call OR_fun on x_totinda, it won't let me because it says it says there's an error in the svyglm.svydesign. So I figured out what that means is that functions don't like to have survey designs in them as one of their components, I guess. So when I put the svyglm command with the survey design outside of the function and then rewrote the function to start with OR table and then to add the health variable column, then to unlist it, then to make it a data frame. And then when I run that function again, but this time I had to wrap the health variable in quotes just because of, just because R gets confused about quotes and not quotes. Anyway, when I did all of this and I ran this function again, it worked. And so actually I set this OR fun parentheses quote extotinda parentheses to an object called A, because what we'll want to do, as we had done in the prevalence estimates video, is run our function over all of our variables and add them like one after the other as rows in a table. So in order to do that, I have to set this function, the call on this function for this variable to an object which I've called A. All right, so when I call A, you see I get our row in the data table. And you'll also see we do get a warning message like we got up here. This is the same warning message that it's coercing it to a list. But you'll see within the function, this is where the warning message comes on this line. But then when we unlist it, then that resolves the warning. So when you run this function that I wrote, you'll get that warning message every time. But that's because R outputs the warning and then it gets resolved within the function. So you can just ignore that warning message because we are resolving it by selecting unlist and then setting as .dataframe. Okay, so what we have to do now is call our odds ratio svyglm function on every single health variable, and then call our OR fun odds ratio function on that same health variable. Because, as you know, I would love to map or iterate or do sapply or lapply or even run a for loop, like just to get this function running over all of our variables. If I could do that in one step, I want to, for sure. But I wasn't able to figure it out in our prevalence estimates videos, and I still couldn't figure it out now. So that's something I'm working on. But I did save us some typing and some copying and pasting by writing the OR_fun function. So what we're going to do is for each health variable, first set our OR odds ratio object to go into this OR_fun function, all right? Because we have to reset our OR object for each health variable. We just did extotinda. Here's X age 5 year, then X RF smoke 3, and then we call the function on that health variable. And we're going to do that across all of our health variables. So let's just do it all. So I'm going to copy and paste all of these. All right. And just run them in the R console. Of course, this code will be available in the description. And we get a bunch of warning messages, but as I said, we resolve it within our function because we unlist it. So you can ignore the warning messages. And now we have a bunch of objects with each row, with each health variable assigned to a row that we want to bind the rows to make a table. Okay, so to bind the rows, we're going to use this command called bind_rows and bind all of these objects, A through M, which are our health variables. We're going to call it all_OR for all odds ratio. And again, it tells us that there are 14 warning messages, but we're ignoring them because we resolved it within our function. Let's look at all_OR. Now we have a table. But just to be consistent, we're going to set that as .dataframe. We're going to set it as a data frame. This is great. This is the first part of our table. And you'll notice in the article, they also have rows for each reference, but that is not interesting at all because the odds ratio for the reference is always 1, and the confidence interval is always reference. So we're only looking at the comparison. So this table is all of the comparisons, which is actually for us, we set our comparison to their reference, okay, because they looked at the negative health behaviors on negative health. We're looking at positive health behaviors on positive health. So, yep, we're just including those values in this table. The next thing that they did, so they have a column for odds ratio. They have another column for adjusted odds ratio. And this is where they just compared each health variable, including all other covariates in the model. So they kept RF health, they kept the self-reported health as a dependent variable, and all of the other covariates as the independent variables. And we are going to accomplish that in just one line. So ALR, we're setting that to ALR, we're setting our object for our adjusted linear regression. So before we set OR, odds ratio, now we're setting ALR, adjusted linear regression. And we're setting our survey GLM, and then we'll call the summary on it. All right, and here we have the health, the self-reported health as the dependent variable, and all of our other factors as the independent variables. Family equals quasi-binomial, and our survey design is right here. So let's run those two lines of code. And this is our output. All right, this is our call. These are our estimates, standard error and t-values, and p-values. Okay, so these are our generalized linear model results. We want our logistic regression analysis results. So we can take the confidence interval again, take exponent again, bind those rows again. Okay, so this is what we did before, looking at the confidence intervals, calling the exponent on the coefficient, so looking at the logistic regression on that survey GLM function, and then binding those two rows so we get the adjusted odds ratio and the confidence interval on the adjusted odds ratio. And we got it. So adjusting for everything else in the model, if you exercise, you have a 1.9 times higher, greater chance of having good health. This age variable is kind of confusing because it's continuous. So, you know, I'm guessing what this means is as you increase in age, your odds of having good health is 0.9. So your adjusted odds ratio goes down a little bit. If you don't smoke, you have a 1.04 greater chance of having good health, you know, adjusting for everything else in the model. So this is our adjusted odds ratio. What we want to do though is drop the first row because the first row is an intercept. All right, so we're going to call the same function except for here in the row spot, we're doing -1. So now we get everything except for the intercept. And we're going to call this ADJ_OR for adjusted odds ratio. And then just call the same function and then set it as a data frame. So I'll just run these two lines at the same time. This is exactly...
Oh, I'm sorry.
So this is exactly what we did with our odds ratio function. You know, I feel like this video is going well. I don't really want to re-record it. I'm in a public space, so somebody just walked in, but we'll ignore it. It's fine. So this is our adjusted odds ratio. We're setting it as a data frame. Let's run those two commands together. Let's now check on our adjusted odds ratio. And, you know, we're seeing the same thing. It's set as a data frame. Now we're going to bind the columns on our all odds ratio and adjusted odds ratio so that we get the full table with the odds ratio and the adjusted odds ratio right next to each other. All right, this is more or less the table that they have in the article, right? Odds ratio, lower and upper limit, the health variable, which is right in the middle, but we can move the position of that later. Adjusted odds ratio, again, the lower and upper limits. So we're going to call that table Table 1, and we're going to look at the column names. Because, as you know, when we have column names that start with something besides a letter, R doesn't like that. So it usually assigns like an X in front of that, in front of the name, if the first character is not a letter. But for these two, on the adjusted odds ratio, the upper and lower limits for that, it didn't change them. So we're going to have to change that manually. Yep. So I'm sorry, you must be hearing so much background noise, but we're going to push through this tutorial. I feel like I'm giving you good information, so we're not going to stop recording. We're going to work through it. All right. So let's reset our table by selecting just the variables and putting them in the order that we want them to be in. So first we want our health variable, then our odds ratio, then our odds ratio, then the confidence intervals on that odds ratio, then the adjusted odds ratio, then the confidence intervals on that adjusted odds ratio. So now when we do that, and we call table 1, we're calling it table 1 because in the article it's also table 1. So now when we look at it, we have things in the correct order. All right, health variable, odds ratio, confidence limits, adjusted odds ratio, confidence interval, lower and upper limit. So now we have to rename all of these weird names on our confidence intervals. We want to rename them to upper limit and lower limit. And actually we'll do odds ratio lower limit, odds ratio upper limit, adjusted odds ratio lower limit, adjusted odds ratio upper limit. And usually you should be able to use the rename function, which is rename. You should be able to use this function, modify names by name, not position. And this should work for you, but for whatever reason, it was not working for me. I wonder if maybe it's because I'm like running a couple of packages and maybe it's the survey package. I don't know. But usually you would just use the rename function. That would be much easier to just do everything in one line of code. But it wasn't working for me, so we have to do manually column by column and rename it. So what we're doing basically is adding a column to table 1 that contains the contents of a column that already exists, but we're giving it a different name. So I'm going to call all of these renaming options. Let's see, is that, yeah, I think that should work. And now when we look at table 1 again, you see we have some duplicate columns. So it's called something else, odds ratio lower limit, but it's actually the same as this x2.5 ... Okay, so now we have a table with duplicate columns. So we're just going to select the columns that we want to keep by using this select function. So we want to keep health variable, odds ratio lower limit, odds ratio upper limit, adjusted odds ratio lower limit, adjusted odds ratio upper limit. So now when we run that, what is this square? That's interesting. I wonder if that affected the command. Let's see, table 1. I guess not. I don't know what that square was. I guess it was just this tab here. Anyway, so when you run this command and you call table 1, you can see that now we have all of our columns and they are named the way that we want them to be named. HV, odds ratio, ORLL, OUUL, AOR, AORLL, AORUL. Okay, so these are basically the columns in the table described by these authors. All right, and we have, every row except the ones that are referenced, because that's the same for every health variable. Reference 1.0. That's not informative to us. But what we do have is the information that we need, our odds ratios and adjusted odds ratios and confidence intervals. All right, so that's our data analysis. As I said, if you want to go back in and calculate for these two columns, the prevalence estimates video tutorials will help you out. So these are unweighted sample sizes and weighted frequencies. You can go ahead and do that. You know how to find the p-values. So, you can really get all of the data from the table that they described here. I don't want this video to last several hours, so I'm just focusing on these last 4 columns. Next, we are going to do some data analysis. So I am not going to close my R session. I'm just going to leave it open and pick up from where we left off. Having said that, I'll end the video now, and I'll see you back here really soon. Bye!